You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. So we've been looking at some really fascinating and honestly conflicting things this week. And it all seems to boil down to this one central tension in technology right now.
It's a great way to put it. It's this clash, isn't it?
Yeah.
On one hand, you have AI agents that are just accelerating software creation to a level that was, frankly, unimaginable a year ago.
Right. Blinding speed.
Exactly. And on the other hand, all that speed is putting so much pressure on our foundations, databases, network protocols, basic security, that it's starting to show the cracks in architectures that were designed back in the 90s.
Yeah, that's it perfectly. So our goal here today is to really navigate that split for you. We want to get at two big questions. First, how are AI agents changing what a developer's job even is anymore?
And second, what ancient rules of computing are finally being broken by the hardware we have today.
It's a massive shift. So let's start with the machine, the AI agent economy, and see what happens when it really gets to work.
Sounds good.
Okay, so the biggest, most immediate takeaway we saw is this. AI agents are starting to go head-to-head with SaaS.
Yeah, not necessarily the huge platform players, but definitely that long tail of tools, mid-market stuff, the internal tooling.
So how does that work? What's the actual mechanism here?
It's really simple. Customization at speed. For years, if you needed, say, a simple internal dashboard or some basic reporting tool, the default was to just buy a SaaS subscription.
Sure, makes sense.
But agents have flipped that script. Now, developers can build bespoke solutions internally, often faster and way cheaper than integrating a third-party product.
And this is especially painful for SaaS companies that are basically just CRU'd apps, right? Create, read, update, delete.
Oh, absolutely. If your whole value prop is just a prettier interface for a database, why would a company pay you a monthly fee when their own developers can get an AI agent to spin up the exact same thing, perfectly customized, for the cost of a few API tokens?
That economic pressure, of course, leads right into the most, I think, controversial conversation in the industry right now.
Job displacement.
Job displacement. Specifically for junior developers, there's this almost panicked idea floating around that companies can just cut their junior devs and fill the gap with AI.
Yeah, and the AWS CEO had a very pointed take on that. He called it one of the dumbest ideas.
Which is pretty definitive.
Yeah.
And the logic behind it is something I think everyone listening really needs to hear.
It's a really strong argument, and it's all about long-term strategy, not just cutting costs. First, the data is showing that junior developers are often the ones who are best at adopting these new AI tools. They're basically digital natives of this LLM era.
So if you cut them, you're cutting your most fluent users of your future toolkit.
You're cutting the very people who are driving the evolution you want. Second, junior staff are your least expensive employees. You don't get huge cost savings there.
Right. It's not like optimizing your cloud spend. Not at all. But the final point is the real killer. If you get rid of junior developers, you are starving your company's talent pipeline. Where do your senior engineers, your principal architects, where do they come from in 5 years if you're not training anyone now?
I absolutely see the logic, especially on the talent pipeline. It's critical. But let's push back on that a little. Even if you keep your junior devs, the work itself is changing. What we're seeing suggests that AI's real superpower here isn't creation, it's consumption.
That is such a fascinating point. The real value isn't just spitting out boilerplate code. It's the analytical power. Think about connecting an AI to your entire company's knowledge base. All the docs, the code history, design files, maybe even your own personal Obsidian vault.
It becomes the ultimate research assistant.
Exactly. It can see patterns, it can connect ideas, it can synthesize things from a huge volume of information that would be literally impossible for a person to process. It consumes knowledge and produces insight. The code is just the artifact of that insight.
And if the AI is handling the implementation part, the actual writing of the code, then the bottleneck in development has completely shifted.
Implementation is now a commodity, which brings us to this idea of the art of vibe design.
Okay, vibe design, I like it.
Since writing the code is commoditized, the thing that makes an engineer successful isn't their ability to execute. It's their ability to articulate a clear vision. It all comes down to the engineer's taste.
Their taste.
Yeah, their aesthetic, their standards, their ability to communicate precisely what the machine should build, and more importantly, why it should look and feel a certain way.
But isn't taste just a fancy word for opinion? I mean, how do you standardize a vibe across a big company?
Well, that's the new challenge, isn't it? You have to define your standards with such incredible clarity that the AI can actually internalize them. The developer becomes more of a system designer, an architect of prompts, than a coder.
So let's unpack that. If the engineer is now a vibe designer, they have to get really, really good at using the tool itself. We have to get past just treating it like a glorified search engine.
It's a total mindset shift. You
Yeah.
have to start treating your coding assistant, whether it's Claude Code or something else, like a new hire that you need to onboard.
Onboard it.
Yeah. The goal is to take it from being this, talented generalist to being an expert who knows your project, your coding style, your personal quirks, without you having to explain it over and over again.
You invest the time to teach it once so you can stop wasting time correcting it later.
That's the whole economy of scale. And a huge theme that kept coming up was memory. How do you make these things remember decisions from one session to the next? We saw examples like Claude-Mem and Code.
How do those work? What are they actually doing?
Well, they observe what the AI is doing, what tools it uses, what files it changes. Then they generate these semantic summaries of its actions. And the key part is, these summaries get injected as relevant context into future sessions. So the AI can literally remember the architectural path it took on a related task last week.
That's a game changer. That gets rid of that Groundhog Day feeling of starting from a blank slate every single time. Okay, so for anyone listening who's struggling with this, what's the most practical advice?
The consensus from the real power users seems to be three things. First, create and maintain a claed.md file in the root of your project. This is your persistent instruction manual for the AI Your Vibe guide.
The machine's manifest. I like that.
Exactly. Second, always use a plan mode. Before you let the AI write a single line of code, make it give you a step-by-step plan. If the plan is wrong, you stop it right there. Saves hours.
Makes sense.
And third, for really critical complex tasks, just use the best model you can get, like an Opus 4.5. The quality jump in handling big, complex problems is absolutely worth the token cost.
That is super actionable. There was one incredible example of this where the AI wasn't just following style, it was defining the style.
Oh, the unofficial 37 Signals Rail style guide. That was a perfect example. A developer basically fed Claude Code the entire fizzy code base, this 37 Signals internal tool, and just told it to figure out their philosophy, to extract the unspoken rules.
So instead of a person writing a style guide based on theory, the AI created one based on what the team actually does, based on empirical evidence from the code itself.
It's machine learning for human taste. It proves the AI can spot those patterns of vibe that the engineers themselves might not even be able to articulate. It just reinforces that the developer's job is becoming about managing these incredibly powerful pattern-matching machines.
Okay, so that's speed and power. It all demands performance, but that demand is where you start to see the fragility in the foundations we all rely on. This is where, for me, it gets really interesting. We're having to rethink the fundamental layers of the web.
We are finally escaping the constraints of the spinning disk. I mean, think about databases. Most relational databases you use today were designed in the 90s or early 2000s. They're built from mechanical hard drives.
And the main constraint of that whole era was
Sequential I/O. Reading data in a big straight line was fast. Random I/O jumping all over the disk to pick up little bits of data was painfully slow. So much of database design was just an elaborate hack to avoid random seeks.
But today, we're all on SSDs and NVMe drives where that's not really a constraint anymore. Random access is nearly as fast as sequential. So the big question now is,
what does a database built from scratch in 2025-1 that sheds all that legacy baggage actually look like?
and the takeaway is what?
The takeaway is that the storage layer isn't the bottleneck anymore. The compute layer is. Modern databases are all about optimizing CPU cache, concurrency, and cutting down on serialization overhead. The entire hierarchy of what's fast and what's slow has been completely rewritten.
And moving to the front end, that same push for speed means we need better ways to diagnose problems. Microsoft is proposing this new delayed message timing API.
Right, which is so important if you're building those big, complex web apps. You're probably using multiple windows or iframes or worker threads. They all talk to each other using messages.
And when one of those messages is slow, good luck figuring out why in the dev tools.
Exactly. You can see the network call, but you can't see what's blocking things internally. This new API would let you diagnose three specific things. Was the receiving end just too busy? Was the task queue congested? Or was it just the overhead from serializing the message itself? That's the kind of detail you need for real debugging.
We also saw some new thinking on optimizing largest contentful paint, LCP. For years, the advice for a bad LCP score has just been make your images smaller.
Which is just treating a symptom, right? The new guidance says you have to break LCP down into 4 distinct parts to know what's really wrong.
Okay, what are they?
You need to look at time to first byte. That's your server speed. Then resource load delay, which is the browser just waiting to start the download. Then resource load duration, the download itself. And finally, element render delay, the time it takes to actually paint the element on screen after it's downloaded.
That's so critical. It tells you if your problem is the server, the network, or the client. You can stop blindly compressing JPEGs if your time to first byte is the real problem.
And on a final, almost funny note on web foundations, the time element.
Ah, yes. The great unfulfilled promise of semantic HTML.
It's such a great idea on paper, right? You wrap a date in a time tag and browsers or screen readers should be able to do smart things with it. But in reality, nothing uses it. No browser, no assistive tech, it just sits there. A great idea that the ecosystem never finished.
So as all this tech gets faster and more complex, especially with AI getting involved in code bases, the security risks just balloon. We have to ground this in the reality of the threats we're seeing right now.
Yeah, we saw 2 really big vulnerabilities this week that highlight different kinds of failure. The first was a critical one in React, an RCE, CVE 2025-55182.
RCE is remote code execution. That's the nightmare scenario.
It's as bad as it gets. This was a flaw deep inside the new React 19 server component infrastructure. And the scary part was it was unauthenticated. An attacker just had to send one single specially crafted HTTP request.
So they didn't need a password? Nothing.
Nothing. It just shows how these new complex architectural patterns, even when they're built for performance, can introduce these devastating zero-day risks if they're not tested to death.
And the second one was different. It was a supply chain attack through that AI documentation platform, Mintlify.
Correct. A hacker found a cross-site scripting and XSS vulnerability. They figured out how to inject malicious code into documentation by messing with SVG files.
And since Mintlify is used by huge companies.
Right. Companies like Discord, Vercel, X, the flaw had this massive downstream impact. It's that classic danger of one weak link in your software supply chain compromising dozens of major platforms.
So what's the takeaway here for the individual developer who's just trying to keep up? With all this complexity, what is the core responsibility of the person writing the code?
I think the core mandate is still the same as it's always been. Your job is to deliver code that you have proven to work.
Proven to work?
Yes. Just submitting a huge untested pull request, especially if it has AI-generated code in it, is a dereliction of duty. You're just passing the risk to your reviewer and to the whole system.
You can't delegate the responsibility even if you delegate the writing.
That's it. Exactly. And proving it works means 2 things that are not negotiable. First, you have to do thorough manual testing yourself. You need to verify it works with your own eyes. And second, you have to bundle automated tests that validate your specific change. AI might write the code, but you are the gatekeeper for quality. That's a core idea we champion here at Vocal Technologist.
It's this profound duality, isn't it? On one side, you have the incredible velocity of AI invention. We're already seeing new models like GPT 5.2 Codex getting better at complex long-term tasks. And that's clashing with the slow, methodical, necessary work of securing and redesigning our core infrastructure.
The future is being built on a foundation that's cracking under the pressure. And we saw that friction perfectly captured in that Cursor CMS migration case this week.
Right. Cursor moved their entire content system from a traditional headless CMS sanity to a pure Markdown and Git-based system, and they used AI agents to do the whole thing.
The headline number was the speed, 3 days. And it only cost them $260 in tokens to migrate everything.
Which is incredibly efficient.
It is. But Sanity pushed back pretty hard. They argued that that speed comes with a huge long-term architectural cost. The new system, they say, struggles with classic problems like content denormalization, poor collaboration for non-technical users, and this is the big one, really limited querying capabilities.
Which is the exact thing you need for those AI consumption tools we were just talking about.
Exactly. It's the difference between getting something done fast and architecting it to last.
Right. So here's the thought we want to leave you with. It's the tension you have to manage in your own projects every day.
If AI agents can successfully migrate your entire content system in 72 hours, is the long-term architectural cost of abstraction, using something like a traditional CMS, still worth the short-term benefits it gives you in collaboration and querying? Where do you, as the developer, draw that line between the raw speed of automation and the deep robustness of good architectural design?
Something to think about. Thanks for joining us for this one. We'll catch you next time.
Spoken Tech for your ears.